Hi everyone. I am Hazi Amshah bin Hassan from Group 5. Today I'll be presenting our EATV project for Automotive Design 1, Section 30. Okay. This is our group members. We are consist of six people for this group. And the first one is Husaini Asfa bin Azizi, Tan Jiayi, Raka Isham Ramadan, Afiq Aiman bin Muhammad, Hazi Amshah bin Hassan, and lastly Muhammad Ronak Safin. Okay, for EATV. EATV is mainly because of the sustainable development goal that we choose to make our project. So beside using traditional all-terrain vehicle, we were tasked to do an electric at all-terrain vehicle. That's why we call EATV. So for the first SDG, we choose the affordable and clean energy. It is for affordable, reliable, and modern energy service. And the second one is industry innovation and infrastructure, SDG number 9. That is for support domestic technology, development, research, and innovation in developing countries. And last SDG we choose for is climate action. Intends to take urgent action in order to combat climate changes and its impacts. This is all the three sustainable development goals that we choose for our ATV project. Design needs. Design need is for our project by comprising the customer needs. So our ATV need to follow the customer needs to get a unit selling price for the ATV to be relevant for usage. So the first one is for design needs is durability, affordable, recyclable, multifunctional vehicle, environmental friendly, aesthetically beautiful, low maintenance, comfortable, easy to operate, high safety, and lastly, reliability. This is all the design needs based on the customer. So we will proceed for the next. Okay, product design specification. Product design specification is our specification for based on the design needs before this another slide before. Okay, the product design specification will follow the engineering requirement to successfully achieve design needs. So all the specification is related to each other. So it will not be nonsense for any component that will not be used to make the project. So only chosen item that we discuss and suggest the best for our design need can be used for this product design specification. So for the first one is the ATV must have a horsepower 45 to 50 horsepower, and the motor type assumptively using AC motor with 500 till 1000 watt, and the torque value is assumptively in 60 to 90 Nm, and the material for chassis is corrosion resistant, heat and water resistant. And for the body material is environmental friendly, recyclable material. The range of the ATV we assume to get 50 kilometers range. The weight for the ATV we assumptively put 200 kilogram. The max load capacity for the ATV is 90 kilogram. The battery type is lead acid battery. The brake system we choose is full set disc brake. And type of tire is 50-50 road and off-road. This type of tire can be used on the road and any off-road terrain. For acoustic, we use front light and rear light. Suspension system, we use double wishbone suspension. And weight ratio, we divide it into two parts. That is front 50% and rear 50%. This is the final CAD drawing for our project. And this is the CAD drawing for the design that we choose. For at the top corner, that is isometric view of final design that was rendered. And from the bottom left is exploded view of final design. We adjust the analysis for using the finite element analysis. This is the static load for the project. At the top corner is static load applied to the chassis. And for the bottom left is mesh plot for static load on chassis. This is the von Mises. This is the finite element analysis for static load. The stress effect on chassis is on the top right. And for the below is the displacement effect on chassis. We can see the difference between the two. Okay, for dynamic load, we can see on the right that is the dynamic load is applied to the chassis. And for the bottom left, we can see the mesh plot for dynamic load on chassis. This is the effect of stress on chassis on the right. And on the left, you can see the displacement effect on chassis. This is the finite element analysis for dynamic load in shape mode. You can see the difference between all of it. And this is the motion analysis for the model. You can see the motion analysis is working because the model is moving forward and bouncing on the same time. So this proof that the motion analysis is successful. Okay, to the next slide. That's all for group 5. Thank you. Thank you for listening, and I will wrap up our slide today. Thank you.